Hi, I have this big neodymium magnet which I bought as a grade N52, the strongest commercially available grade, so this magnet should be very strong for its size. I bought it on eBay where it was cheaper than branded magnets of the same size and grade. The thing is, it just feels like it is lacking a bit in power. I wonder if I can measure the grade of it. Let's find out. Be careful when handling big neodymium magnets. Don't let the big magnets bite you. I have an idea on how to test the grade of a magnet, or at least a method for an indication of it. But starting with the magnet from a questionable source will not be a good test of whether the method works or not. As a control test, I would therefore like to start off with the magnet I have more trust in. This magnet is sold as a grade N40, a medium grade that is much easier to mass produce than grade N52 that almost all magnets on eBay are sold as. Perhaps because the sellers know people search for the ultimate N52. Since this magnet does not seem to be marketed with an exaggerated grade, it is much more likely to be honest and realistic. Good for a control test. The method I will use is to measure the magnetic field strength at the exact center of the magnet. I will then compare it to a calculated theoretical value for each grade. Finding the center of a block magnet is easy. Just draw the two diagonals from corner to corner and X marks the spot. For the measurements, I'll first use my high precision 3-axis Tesla meter. I will only need the Z axis value in this case, so let me zoom in on the values. The field strength on this magnet's center is around 3.95 kilogauss. In case you are wondering, the field strength on the other pole is basically the same, just with reverse polarity. It should be for any healthy symmetrical magnet, so I will only measure on one side for the next magnets. But for extra confidence on the field strength, I will double check with my other Gauss meter. Yeah, I'm measuring in Tesla on the Gauss meter and Gauss on the Tesla meter, because I'm a lazy boy and that's the setting the meters were used on last, and the units are interchangeable anyway. Looks like it is around the same 3.96 kilogauss. Okay, the value on the center is around 3955 gauss, but this value is a bit arbitrary without a reference. What grade does this value represent? I will use a spreadsheet for calculating the values for each grade, a spreadsheet downloaded from Supermagnet's website. The formulas used are relatively recent and simple, but should be good enough for an indication of the grade. Links for it all in the description under the video. I am using Google Sheets since I don't have Excel. Alright, let's enter the size of the magnet. It is 2 inches by 2 inches and 1 inch in thickness. The sensor's distance to the surface of the magnet is also needed. For the Z-axis sensor, it is around 0.35 mm, though it may vary by plus minus 0.3 mm. I will use the nominal 0.35. It is precise enough for an indication and seems comparable with the sensor depth on the other probe, though it isn't specified for this one. Now, all I need to do is to choose the different grades and list the expected flux densities. This is where it gets more tricky. Grade is not an exact value as these calculations might suggest. No two magnets are exactly the same throughout, on a molecular level, even when formed from the same batch of material. So a grade is actually a range, as explained in an old video of mine, where magnets are allowed to have slightly different strengths within the same grade. Grade N40 means the magnet has a maximum energy product in the range above 38 megagauss Ørsted up to and including 40 megagauss Ørsted. With that in mind, I believe the expected values from the spreadsheet should be arranged like this for each grade range. Let's see where the actual measurement from the N40 magnets fits in. Okay, a little on the low side, but within the N40 range. Maybe this method does work. I have another one of these magnets for a second check. This one in a limited edition with orange epoxy coating. I received the one with serial number 13. That has a nice ring to it. Imagine if I had the one with serial number 6662 and combined them to a 2-inch cube magnet. It has the same specs as the first one, but I expect it to read a tiny bit lower since the epoxy coating adds another layer and distance to the magnetic material. The cross marks the center. Well, there goes my expectations. It is not measuring lower, it is measuring higher. Will the other Gauss meter confirm it? Yep, it measures the same. Looks like this spot measurement method may not be the most reliable. In reality, a flux meter measuring the whole magnet at once is much more reliable, but I don't have one. At least I have confirmed that two magnets of the same size and grade do not necessarily perform exactly the same at the center. That's why grades are ranges and not a precise value in the first place. In real life, the only 4% difference in Gauss reading between the two magnets will hardly make any difference in a practical application. And both measurements are sitting around the N40 range, not close to N30 or N50. So for me, it is precise enough for an indication of whether this is an N52 magnet or not. We need new calculations since this is a different size and shape. Hold on. Now I need to find the center of the magnet. Trickier with a circle. I will use chords to find it. It is easy with this protractor since it has a notch I can slide in over the magnet. When it can't go any further, I draw the chord and mark the center of it. From the center, I draw the perpendicular line which will pass through the center of the magnet. Then I draw another random one. The center of the circle is where the two perpendicular lines meet. 2 is enough in theory, but I'll draw a third one in case I messed up one of the first two. Looks alright. The center of the magnet is right around here. Time to measure. Around 3250 Gauss. And 3260 Gauss on the other. Does this reading equals a grade N52 as the seller listed it as? I may have been tricked. Before I call it, I have a branded N52 magnet of the same size. Will this measure higher, or is my method flawed? It is measuring higher. Will it go all the way up to the ultimate N52 range? Yes it does. Only just, but still impressive since N52 calls for perfection in every production step. And perfection on a molecular level gets trickier the larger magnet you want to make. Seems like they got it right for this one, but not for the unbranded one. It may pass as an N48, which isn't bad, but it is not an N52. Bummer. Click like if you dislike cheating sellers. With that said, I would like to point out that you don't need grade N52 to have a strong magnet. Don't be too obsessed with grade. Grade is only one factor when looking at the strength of a magnet. Size and form factor also matter, so don't underestimate the strength of a big N40 magnet. You may have noticed the center of the smaller and lower grade N40 block magnet is stronger than on the bigger and higher grade N52 disc magnet. Here are the results on a full scale from 0 Gauss. Sure, it is only a spot measurement, not the overall strength of the magnet, but the N40 magnet is not weak. If you want to see more on how the magnetic field is distributed on and around a magnet, I have a video where I map the field of my two strongest magnets. including how far the magnetic field extends and why the center may appear relatively weak on white magnets. Worth a look. Links in all the usual places. Alright, how do I conclude this? Can you measure the grade of a magnet at home if you have a Gauss meter? I'm leaning towards no, if you expect high accuracy. Even with a research-grade Tesla meter, you have to be precise down to fractions of a millimeter when measuring. And I'm not sure how well the theoretical formulas work for very large or small magnets. But I do believe you can get an indication of whether a magnet is closest to being an N40 or N52 if you are careful and meticulous. I may do further testing of this method, including the more challenging ring and sphere magnets. Let me know in a comment what you think of it. Thanks to all my patrons. It's really appreciated, not just by me, but also by my many viewers who don't have $1 to spare. Keeping niche videos like this one coming is not easy on my own, but luckily some of you help me keep going through Patreon. In case you can and want to help me out, I have a link for my Patreon page in the description. Thank you. And thanks for watching. Bye for now.